Good morning, good afternoon, or good evening, depending on where you're at in the world today. We're going to begin our webinar in just a moment or two. We want to give the latecomers a moment to get settled. And I wanted to briefly cover some housekeeping items before we jump in. If you want to ask a question today, there is a questions chat box in your GoToWebinar interface. This is your chance to ask a real person a question about the topic at hand. So I encourage you to take advantage of that opportunity, and we will get started in just one moment. Thank you. Hello again, and welcome to today's webinar, Harnessing the Power of Real-Time Analytics for Rapid Decision Making. My name is Chris Burns. I'm a Solutions Architect at AWS, and joining me today, I have Thor List, Senior Solutions Architect at Databricks, and Stephen Galsworthy, the Chief Data Officer of Cuba. Thor and Stephen have some excellent information to share with us today. Demos and how-tos are great when they're coming from AWS, for people like myself, but it's so much better to hear how our partners and how their customers are using the platform in real world scenarios. So these are real solutions by real people that you're going to hear about today. Now, before we get to that, I want to briefly share the agenda with you for the next hour. It's a simple but informative agenda today. First, I'm going to take a moment and I'm going to talk about streaming, just in general, generic streaming on AWS. We'll dive into Amazon Kinesis just a little bit. Then Thor's going to walk us through streaming on AWS with Databricks. And you're going to see the benefits of adding Databricks to the primitives that we offer at AWS. And then finally, Stephen's going to talk about Cuba's story and some examples of how you can use, how they use their services, how they've created their services, using Databricks and AWS to deliver a customer-obsessed outcome. And I did it right out of the gate. I apologize for the slide there. So let's talk about streaming. So specifically, I want to take a moment and I want to level set. I'm sure we have a wide range of experience amongst our attendees. So if the veterans of streaming will just pardon me for one moment, I want to define data streaming at a low level. And the simplest definition is that streaming data is that you're streaming continuously generated data. Unlike a single file transfer, it's a continuous flow of traffic. And the other tenet of streaming data is that the processing on that data begins without knowing when you will reach the end of stream or when the end of that data transfer is going to take place. So those are really your tenets of streaming. It's going to be a continuous stream of data, and really you're going to begin processing before you know when the data stream is going to end. You don't wait until that file transfer or that data transfer is complete. So why use streams? The quick answer is speed. I'm old enough to remember when the bottlenecks of solution design were network hardware. I'm showing my age a little bit here, but I'm talking about the Kermit protocol over 14K modems. This is all fortunately ancient history. Today, the inverse is sort of true. We have, with the exception of some wireless networks, the bottleneck is almost in the software design, in the architecture of the solutions that process the data streams. How do we keep up with the flow of traffic, with the flow of data coming into our solutions? Now, I mentioned speed a moment ago, and I can give a better definition than that. Obviously, speed is great, but what is the goal here? The goal is real time, as near real time as possible when we're talking about speed. So we're going to a couple examples of streaming that you may have read while I was chatting there is video is a tremendous popular use of streaming, making new data available for analytics and processing in seconds. We're going to dive into that in just a little bit here. You want to get the insights in real time and you want to be able to react quickly. So this sort of transcends the whole agile concept to moving even more faster than what we call agile to real time. And examples of some real time data are security and home camera feeds. You certainly don't want to delay the response or the processing of the data if there's an event at your home or security related. And we have application logs, click streams, and obviously Internet of Things sensor data. I want to take a look at a simple pattern for streaming data here. So you have a mobile client. Now the mobile client, it's a fantastic example of a data producer. It's continuously creates data. And I'm not just talking about your teenager's Twitter feed or Instagram account. If you think about the mobile platform, even before we get to the apps, there's GPS, there's gyroscope, there's accelerometer, there's magnetometer, I can't even, or meter, I can't even pronounce it correctly. You have a transceiver that's establishing and maintaining cellular connectivity. The mobile platform is constantly generating data at multiple levels. And in this pattern, we have Amazon Kinesis. So an introduction to Kinesis. It's a service that makes it easy to collect, process, and analyze real-time streaming data so that you can get timely insights and react quickly to the new information. Creating the plumbing for these type of applications is not trivial and it's not fun. I was a developer for a number of years, and creating the substrate, or the what I like to call the plumbing for these type of applications is tedious, it's error prone, and it's not something you want to get into. A service like Kinesis is sort of, if I could still use the phrase, plug and play, and it's ready for you immediately out of the box. And Kinesis, it's your friend that abstracts all the complexities of handling that data and just get right to your code. So you can simply consume a clean API to reliably store data, provide temporary buffer where you can prepare that data for processing, and it allows your application to support very high throughput without the need to write that low-level code. And then the third component of this very simple pattern is the Amazon Kinesis app, which is really your application. This is your code, the consumer of the data. And this is where your code comes into play. This is where you can spend your time and focus rather than on that substrate that I had mentioned previously. Now, in tech years, Kinesis is incredibly mature. It was released in 2013, way back then, and during its lifetime, it has seen a number of additional enhancements and purpose-built features, making it even easier for developers to focus on what's important to their application and less on the data handling. So we have specific features for Kinesis video streams, and just like its name suggests, it makes it easy to securely stream video from connected devices to AWS. We have Kinesis data streams, slightly different here. These are scalable, they're durable, they're continuous capture and processing of gigabytes of data per second. When you're working with data, changes are not, when you're working with data, changes are, and it's not from a single source. Chances are it's not from a single source. Kinesis handles this multi-source problem for you, and you can capture data from hundreds of thousands of sources. So I've sort of introduced a new paradigm here. Not only do you want to process this data in real time in a very, very high throughput, but you want to process it from many, many thousands of sources. We have a Kinesis data fire hose. We could say that this is similar to the data stream, but this is for data that you don't need to pre-process. Maybe you don't need to analyze it on the fly. You just need to capture this high throughput stream of data to a different AWS service or some type of data store. So data fire hose will take care of that for you. And then, of course, we have data analytics. If you have a scenario where you need to analyze data on the fly, perhaps you need to pull out particular points of data from this stream, or you have multiple routes that this stream can take, and you need to ask the stream a question, in essence, before you begin that routing. We offer data and analytics that, in SQL, in Java, to analyze your data. So here we have an example of how individual components of Kinesis could work together. So if we take a social media stream, you can uncover legitimate sentiment analysis and trends with these. You can leverage hashtags as metadata, and you can really measure brand penetration. As an AI ML specialist, last year I wanted to see which of the 13 AI-related announcements at reInvent was generating the most mentions on Twitter. So I created a process that consumed the Twitter API. I used some analytics to sort. I used some Lambda to write to DynamoDB for persistence, and then fast access afterwards to see the results. And the result was ultimately, it was something I scraped together in a very short amount of time, but it was a near real-time, scalable, serverless application that provided legitimate insights to a question that I had asked myself. I want to be mindful of time here, so I'm going to try to not talk any faster than I am, but as quickly as possible. So this is a slide that we like to include at AWS in our presentations. It's easy to sit here and listen to somebody that works for AWS talk about how great an AWS service is, but these are some of our customers. These are some of the solutions that I'm sure that most of you have heard of in one way or another. And what this represents is these are millions, tens of millions, billions of events in near real time that are being processed by our customers with Amazon Kinesis. And then finally, I have a little bit more of a mature reference architecture here rather than the conceptual design we saw just a moment ago. This is the ability to consume multiple data streams from different types of sources. So that you see here, we have clickstream data, we have log data, we have IoT telemetry. Maybe you're involved in a sensor fusion type scenario where you need to take data from multiple sensors as rapidly as possible in order to react. I'm thinking of autonomous driving. I'm thinking of a lot of IoT autonomous control mechanisms here. And Kinesis is going to collect this data for you. It's going to allow you to analyze it in multiple levels, multiple tiers, and multiple manners. And this is also where I'm going to introduce Databricks for the first time. Databricks is a fantastic platform for in-depth analysis, for introducing machine learning into your analytics, and for handling data if you're using a Spark type scenario for data persistence. And with that, my time is over. You've survived this section of the webinar. It's my pleasure to introduce to you Thor List, a Senior Solutions Architect at Databricks. Thor?
Hello, and thank you very much for the invitation to come and speak here. That was a great introduction, Chris. I really enjoyed that. So my name is Thor List. I'm a Senior Solutions Architect with Databricks. It was interesting to hear you define maturity as if it had been around since 2013. It was very mature. That was exactly when Databricks was founded as well. So I guess we are now, by the digital age standard, mature. We were founded by the founders of the creators of the Spark language. So the Spark language grew out of Berkeley University, and the founders of our company are still with us, and they are still very active in the open source community, both in Spark and in some of the other technologies that we've been working on. Our vision has always been to basically to unify all of the different parts of data engineering, data science, and business, because they normally live in silos. You've got the engineers sitting in one room, scientists are over in the other room, and the business people are just wishing that something magical will happen. Our product will allow everybody to work within the same environment to really visualize, work with the data from ingestion to the outcome. And to fulfill this, we came up with our unified analytics platform as a product. Its foundation is Apache Spark. We have probably done some optimizations to make it run even faster than the open source version, but essentially it is the open source version that we're running. We are hosting it. I would say that we grew up on AWS. We've been with AWS ever since we started, and we're natively optimized to get the best performance, the most power out of the platform as it is today. As I said, we still contribute about 75% of our code, the changes to Apache Spark. And we are also, because we are Spark experts, we do a lot of training, a lot of professional services, and we work with a very, very wide range of customers. So the customers that we work with, here is an example. Oh, that was a little bit too far. So you can see that we're working with customers from all over, all different types of markets, so from financial services to consumer services to energy to technology. So and we really we offer them whole solutions, end-to-end solutions, from ETL, engineering, data science, machine learning. We offer them the ability to mix and match batch and streaming. We work with, for Shell, we're working with predictive maintenance. For hotels.com, we work with recommendations. We work with customer churn. And every single week, almost, we grow our customer base significantly. Artificial intelligence, well, obviously it has been around for like tens of years. What has really changed is not necessarily the algorithms, but what we have seen is it's the availability of data. So now we have enough data to make the algorithms that were invented in the 60s and 70s and 80s actually do something really, really, really useful. If you put 100 images through one of these, you might get an interesting result. if you put 10 million images through them, you will get something that is truly astonishing. So artificial intelligence goes hand in hand with big data. And what we see is, as Chris described before, we see that customers want to use lots of different types of data: static data, streams, sensor data, video, and all of this goes into the data engineering part, which will work and sort of make value out of this. But as we've also seen, many companies have tried to do this, and most of them have actually failed because AI is really, really hard. Not necessarily because the algorithms are hard, but it's because the whole infrastructure needs to be there to make everything available. From you work with the data, you sort out what you want to do, which features you want to work with, then you want to do the actual machine learning. And once you've done that, you want to productionize and put everything out there so that it can be used in the real world, and then repeat. So what Databricks offers on AWS is that we have a total solution that will allow everybody to collaborate really well without having to spend endless amounts of time worrying about resources and clusters and where the data comes from and where it should go. That we make best use of the AWS ecosystem. We work with most of the other AWS bits in there. But what we then have is we have a Spark engine that will allow you to process your big data on a very, very large cluster. And you can create that cluster in less than 2 minutes. It is that easy. We also allow different people to collaborate. We have a very useful sort of an intuitive notebook interface where multiple people can work together in the same notebook or side by side on projects. And then we have Delta and ML Flow, which you might have heard of. So Delta is a way for us to make sense of the data lake. The data lake often was, once it got big, it was really hard to work with. With Delta, you can enforce schema, you can do time travel, you have ACID transactions. It's truly unique, and you should really go and have a look at it. We have open sourced that technology as well. And then I wanted to talk a little bit about streaming. So Spark originally was working quite well with streaming, but what we have done in collaboration with AWS is we have made it a first-party part of the Spark ecosystem. So streaming data has always been very difficult to work with if you also wanted to work with static data at the same time. You've got batch, you've got streaming, and that was, to be honest, one of the reasons that we invented Delta, because with Delta you have the ability to write and read from data tables, both in streaming and in batch mode. When we then integrate with, for instance, Amazon Kinesis, it is very easy for us to work with structured streaming. We have a native Kinesis connector, and then with the Databricks runtime, you do Spark. You can either do that in Scala, in Python, in R, or simply just use SQL if you're more comfortable with that. And it really, really works very well. At the other end, you would then serve this data up either as sort of raw data, semi-processed, or as we call gold style tables, which is ready for machine learning. And just to give a little bit before we hand over to QB about what type of stuff that we do with our customers, to dig a little bit deeper. We were working with Viacom. They are obviously streaming petabytes of data, and that is a significant challenge to make sure that that is optimized and has good quality of service. By leveraging machine learning, we were able to work with Viacom to give the customers a much better sort of an improved experience, which then led to customer retention. With Rulala, we were able to process 400 gigabytes of data, And the main thing we did really was to cut down on the ETL time, because ETL, the processing of data as it comes in, making it ready, that's a big challenge. We were able to cut down on that while accelerating model training by 25 times. So a factor of 25. That meant that they could train many more models. It'd be much more interesting. And then we worked with Edmunds, where we designed a new advertisement solution. So they work with automated bids or bids analysis on Facebook ads, and they were able to deliver much more targeted advertisement, which generated 50 million in the first year of the product, and obviously continues to this day. So I hope that has given you a little bit of an idea of what we do as Databricks. And obviously, if you want to have a closer look, just go to databricks.com. We've got a community edition. It's free. Sign up, play with it, and we are very happy to answer any questions that you have. And I think at this point, I will hand over to Stephen from Cuba.
Hi, very pleased to be on the webinar with you all. We are Cuba. We are a company based in Amsterdam. We are around about 100 people in total, around about 10% of which are working with data on a daily basis, so data scientists, data engineers. My role at Cuba, I'm the Chief Data Officer. That means that I'm really engaged with developing a lot of services based on IoT data, and also looking at how that integrates with our product and our strategy going forwards. So Cuba's been around for over 15 years. We are typically partnering with different companies in the ecosystem. So for example, utilities and insurance companies. We're typically taking IoT data, translating that into insights to give a very good customer experience for these customers, particularly from industries such as utilities and insurance, where the commodity product is of limited interest on its own. We've already kicked off in the Netherlands, where we have a large share of the Smart Thermostat installations in this country. We've expanded up to around about 500,000 homes across Europe right now. I think what's really interesting for the topic of the conversation today is that we're collecting terabytes of IoT data every day. Before we get into the details of the data, I want to tell you a little bit more about Cuba as a company. So we were founded originally back in 2004. So this was a real long time ago, way before IoT was mentioned as a term by the general public. We really came to the market in prominence back in 2012, where we launched our original Smart Thermostat, which is marketed as the Tone thermostat for anyone who's listening from the Netherlands. Then over a number of years, we've rolled out this into hundreds of thousands of homes across Europe. We formed a partnership with NG Electrabel, who are one of the largest electricity companies in Belgium, and also with Repsol, who are a very large Spanish utility. Just last year, we moved away from solely concentrating on the energy space into also the insurance space, where we've partnered with a company called Interpolis, which is one of the large insurers in the Netherlands. And we've launched a security proposition with them, as well as very recently moving away from just IoT data coming solely from our smart thermostats into what are the possibilities just using smart meter data on its own. So to give you all a little bit of a flavor for what we do at Cuba, we're typically focusing on home services. So from our perspective, we see that residents within homes typically have three kind of pillars that they're focusing on. One is having an efficient home, so not wasting resources in your home, making sure that it's that you're having a home at a comfortable temperature, but you're not just wasting heat and energy for the sake of it. Very closely related to that is people want to be comfortable within the home. They want to be able to access things very quickly, be able to turn on lighting, have the boiler at the right temperature. And then finally, people really have the desire to trust things in the home. So the home itself, but also the loved ones within that home. So to give you a little bit of an idea of the kind of data we're collecting, I want to dive into a bit of detail in our smart thermostat. So if you can see here that our smart thermostat is a touchscreen device that's typically located within the living room. So we're able there really to engage with people through the screen, and this is also connected to our app for control. The thermostat quite naturally is connected to the heating system. The majority of homes in the Netherlands have a gas central heating system, which is shown in the top right. We're also connected to the electricity, gas, and water meters. So we can really make a great link between controlling the comfort in someone's home, but also giving them insight into how they're using these different commodities. We've also expanded out into various smart home features. So relating to electricity, if you have solar panels on your roof, our hardware allows you to see in real time how that is being consumed. Also can hook up with home batteries, smart plugs, and smart smoke detectors, which allow you to get alerts if your home is if the smoke alarm is being set off in your home, as well as the ability over Wi-Fi to interact with smart speakers, smart lighting, and also a number of third-party apps that are hooking into our ecosystem. So to summarize, our challenges is we've really been growing our customer base quite rapidly across multiple countries at the same time, and that's leading to a huge amount of IoT data. On top of this data, we're wanting to deliver home services, and to do that at scale, we really need efficient support for those pipelines to run those analytics. We need to process IoT data both in a batch way and in a streaming way. It needs to be both reliable and efficient. And if you concentrate more on the human aspect of that, we've got a growing team of data scientists and engineers that need to be able to work together, develop these services in a very quick, robust way, and be able to get insight into the data and to grow possibilities on top of that. So what I want to do today is take you through two services that we've developed based on the data. So the first one is a service called the waste checker. This is something that we use to detect inefficient appliances and behaviors within homes. So what we're doing there is we're taking data from a number of sources within the home. So for example, the gas meter, the electricity meter, the central heating system, or the water sensor. We're running some machine learning algorithms on top of that, and we're giving an indication to our end users of whether their appliances are efficient or not. So what we're able to do there is by using these algorithms, we can detect people that are using their washing machine at a very high temperature for a wash every cycle, or we can identify a dishwasher that is maybe using a large amount of energy because it's just 15 years old and there would be a more efficient model available on the market. So getting into the pipeline of that, what we're doing is we're collecting data from all of these IoT devices that are out there. So generally coming, in this example, coming via our smart thermostat. We're collecting that. We're using the Amazon API gateway. Then we take all of that data, we're storing that in S3, and typically for batch analytics, we're storing that in a Hive table. We're then able to run batch analytics on this data, typically on a daily basis for the waste checker. Then we run a lot of deep learning algorithms based on that data. And then we're showing the insight based within our mobile app. So we're currently running this. We've got hundreds of thousands of users using this service on a daily basis. What I think is particularly relevant for the webinar today is if you're a company and you want to do, you've got a nice batch analytics setup running, what happens if you have a use case where you want to do something with streaming on top of that? How do you go about doing so? I'm going to introduce a second service, which really do need to do in real time. So what we're doing is we want to alert people when there's problems with their heating system before they notice that their home is getting cold. So what we're doing there was we're monitoring the boiler and the thermostat data on a constant basis. So this is from our connection to the central heating system, and also the fact that we've got this thermostat typically installed in the living room. So by taking these multiple sensors, these multiple data streams, we're able to run algorithms on top of that determine when the heating system is leaving its normal operating range. Then what we want to be able to do is to take into account some of the user preferences, some of the severity of that, and then we want to send an alert to the user. So from the user perspective, they're going to get an alert saying it looks like something's up with your heating. You might want to check it out. So how does this work from the pipeline perspective? So you'll notice a lot of similarities with what the slide I showed previously. So again, we're collecting the data from the IoT devices. We're running that through the Amazon API gateway, but then we're adding in the ability to handle the streams directly with Kinesis. There's a lot of benefits for using that there. It's not just for speed, it's also for the simplicity and the reliability. We're then taking that back again into the Databricks environment. We're again storing the data in Amazon S3, but instead of working with a Hive table, we've upgraded that table to a Delta table. That means that not only can we do the batch analytics to give the information that's needed for the waste checker service within the app, but we can also run some streaming analytics on top of that. So what we're able to do then, by using a really nice service, Amazon SQS, or a simple queue service, we're then able to put this onto a queue. We're able to pick this up, and then an alert is sent to the right user exactly the right time. So in total, this means we've got a boiler monitoring service that's running in conjunction with a waste checker service. I want to pick out a few things I think are really useful to know. So the Delta table on the Databricks platform, it's a very simple upgrade. I mean, it's literally a few clicks. What you're getting on top of that, as well as the ability of running both batch and streaming at the same time from the same data set, you're talking in terms of being able to enforce some schemas on there, and there's a lot of really useful tools that make the Delta table a much more natural way of engaging with data sets that are available. What we find is that in total, we're handling a huge amount of data. We've got a vast data lake, petabytes worth of IoT data. Being able to have a very simple pipeline is very key for us, because essentially we've got a lot of the complexity that we have is within the algorithms they're running. So we want to strip back and make the whole of the rest of the data pipeline as streamlined as possible. We've deliberately made the choice of partnering both with Databricks and AWS. One thing that does is it means that we're able to support running a lot of these services at huge scale with a relatively small data engineering team. That allows us that we can really, within QB, we can concentrate our focus on where my colleagues can really add value. So this is figuring out new use cases, engaging with our customers, figuring out what the end users want to see, and making that work at scale and offering new improved functionality. So just to wrap things up, what we really see from this approach with QB is using Databricks and AWS, we've got this simplified end-to-end data analytics. We can work with both batch and streaming at the same time, and we can mix and match the two. We've got a huge benefit of cost savings in comparison to an on-premise cluster. So this comes from both the inherent efficiencies from the AWS cloud, but also through Databricks, we've got a lot of infrastructure management capabilities. So for example, think of things like cluster timeouts, auto scaling, access to spot instances. When you're running these pipelines at scale, even fractions of a percent of savings can really add up. And a lot of the components that are available to us both on the AWS and Databricks platforms allow us to make some very optimal pipelines. As Thor was mentioning earlier, the Databricks interactive workspace has got some really useful functionalities to it. So we've got a team, data scientists, engineers, that they're developing code on this all together. One thing that I really like is the ability to, within a single Databricks notebook, if you want to write one cell in Python, then you very quickly want to switch, write something in Scala, or maybe just add in a simple SQL query. It's very quick to be able to switch between all of these different languages. Also, multiple data scientists being able to work on the platform at the same time. That really helps, particularly in the early stages of testing out a concept. When you get more to the production environment, you're able to link the code through Databricks with your favorite IDE. But it allows lots of possibilities there. So in total, this has really powered QB's transformation from in the past, we were really focusing on our hardware services. We have a very long, rich history in both energy displays and smart thermostats. By working with AWS and Databricks, we've been able to collect huge amounts of data. We've been able to run machine learning algorithms at scale on this data and really be able to develop some unique services that we can offer via our B2B utility and insurance company partners. That's really enabling us to set ourselves apart in the market. And now I would really say that we're a data-driven, AI-first company. So I hope you've enjoyed the story that we've taken through with you today, really showing how QB has been able to benefit from certain functionalities. And I hope you're able to start thinking about how your business can achieve something as successful. And Chris, would you like to pick this back up from AWS?
Absolutely, Stephen. Thank you very much for that wonderful overview of your product. Quite a few fascinating details in there, and it's impressive to just think about the orchestration that goes on behind the scenes to manage the amount of data and the complexity of the data. So at this point in the webinar, hopefully we've whetted your appetite a little bit to go and build. And so if you're interested in how to get started, AWS offers a number of resources to get you in the door, to get your foot wet, so to speak. You can start small or you can start big. Our services, of course, are pay as you go, and most of them have free trials. So there's plenty of opportunity to kick the tires before you make significant investments. And everybody's going to get a copy of this webinar in via email after the webinar. We're going to send out an email with a link to it. So if you're worried about missing some slides or going back to see some slides, just rest assured you're going to have access to those. And I say that because I wanted to point you to these links here. Anytime you have a question about an AWS product, it's almost always aws.amazon.com/product. So we see here Amazon Kinesis, and I encourage you to go there. There's going to be plenty of links to documentation, to getting started guides, to reference architectures, everything that you would need to begin a project. And also you can feel free to reach out to me as a partner solutions architect. My role here at AWS is to offer assistance to the partners that have questions about these services and features. And then finally, we have come to our Q&A session. So I hope you took my advice at the beginning of the webinar. I hope you put some questions into the questions box. And also, if you did not put a question in there, I encourage you to stick around, because oftentimes there are great questions asked at this part of the session, and very insightful answers offered up. So I'm going to dig into our question bag here, and the first one looks like it's going to be for Thor. And it's a question about expanding a little bit more on the time travel feature and how it's used and maintained. So Thor, what can you tell us about the time travel feature?
Yeah, time travel is always, I mean, obviously it's fascinating, but in terms of data science, it is such a valuable tool. What we offer now with Delta is the ability to essentially wrap your standard big data in Parquet format uh, in metadata. Now that provides a shield so that when multiple people are reading and writing at the same time, they always have consistency. If a job fails halfway through, then either the data is written or is not written using like a very protective commit scheme. And that enables us to do very, very detailed data logging of who did what when. That's all maintained in there. And that means that I can now go in and ask basically my question. I could do a SQL query, or you could do it in Spark, you could do it in Python or R. But in SQL, you would basically say, select star from this table as it was yesterday at 2 o'clock or a week ago at 5 in the morning. And basically what you then get back is the data as it looked back then. Now that includes schema evolution. So if you have changed the schema because you've added some tables in the meantime, then when you use time travel and you go and read the data as it was a week ago, you get it as the schema was a week ago. Whereas if you read the data as it was now or yesterday, you would get the new schema. It's very, very powerful. People or our customers use that a lot for machine learning. So imagine that you train your machine learning model on a certain data set, and you have spent hours and hours training lots of different, like running lots of different training sessions. You've logged it all, and now a week later, you want to just do a few more training runs. But obviously the data has moved on since then. Lots of data has been added. Some might have been deleted. And then when you try to run your machine learning model on that, you would not be comparing apples to apples. Whereas if you can go and run your machine learning algorithm on the data as it was when you last ran your models a week ago, you would then be able to compare the two machine learning models like for like. I hope that answers the question. If not, then I'm very happy to speak to Michael in more detail after this show.
Great, thank you very much, Thor. It looks like the next section, if I can call it a section of questions, are going to be for Stephen, and it looks like the folks want to talk a little bit about ML. So Stephen, without obviously revealing any secret sauce, are you able to talk about which type of machine learning algorithms QB's product uses?
Yeah, certainly. We use a wide variety. So if we think back to our waste checker service, which is the one that I talked about back on slide 20, I think, in the presentation. There we're really trying to pick out different inefficiencies in appliances. We're using a wide variety of different algorithms. So we're using everything from an expert-based system. So for example, detecting hot water usage, all the way through to a few random forest approaches, all the way through which we're using for our dryer detections is a deep learning based model. So we've evolved this over time, and I think what's really interesting is, and it relates a little bit back to the training that we've talked about earlier. We were able to train our algorithms based on a training set that we'd gone out and collected by essentially giving smart plugs for people to install in their homes, and specifically asking them to connect that smart plug to a specific appliance, maybe the washing machine or the dishwasher. That gave us, at the time, a very large training set. So we, relative to the rest of the market, so I think we were up to around about 200 homes that had this installed. Over time, you start seeing that 200 homes seems quite small in comparison to a few 100,000. So then we're able to use the information that's coming from our users of using the product. Maybe we have inadvertently detected a dishwasher at that home, but they don't own a dishwasher. We get that feedback, and we can really turn that back into the training set and use that to improve the algorithms. Obviously, if you're based on more of an expert-based system, there's limited things you can do. When you get into deep learning, for sure, this is really where you can pick up and fine-tune the algorithms to really get that fine detail. What we find from detecting information from the electricity meter data, it's a little bit like processing a speech or a sort of voice. So it's a time series data. And it's relatively easy to pick out the voice. You can think of it as a voice of a washing machine if the washing machine is the only thing happening. But imagine you've got 100 people speaking in the room at the same time. If you want to pick out that specific appliance, then that's where the deep learning algorithms can really come into their own. I hope that answers your question. We'd be happy to go into more detail, and I'd encourage any participants to check out our website if they want to learn a little bit more about specifically what QB are doing in that area.
Oh, that's fantastic. Thank you, Steve. So I want to bounce this back to Thor real quick. And Thor, could you tell our audience? I've used the Databricks product myself quite a few times. Could you highlight just for a moment on the wide range of ML algorithms that are available on the Databricks platform? I'm talking about from your simple classical machine learning regression all the way to deep learning.
Yes, I'd be happy to. One of the strengths of the Databricks platform is that when you log in and you start using the notebooks, you've essentially got everything you need right there. When you start up a machine learning notebook, you will have pretty much all of the mainstream machine learning libraries available, already loaded, ready to use. That would be like TensorFlow, Keras, Scikit-learn, and they all are there, ready, loaded up, and moreover, all the versions of them will fit perfectly within the Spark architecture. So some of them are even scalable, so you can scale them up very easily to run on multiple nodes at the same time. And all of this comes from us having tested it very thoroughly before we release our versions, so that you, as in the users, will get a coherent experience where everything is there. Now, we do have a couple of customers that come along and they have either their own machine learning libraries, or they have the requirement that they need to use a very specific version of TensorFlow. Then it's very easy in our platform to go and load libraries. And if it's more complicated than that, you can even have a Docker image that you superimpose on top of your environment, which will then give you everything you need. And basically, we haven't really sort of encountered many people who have been unable to use pretty much whatever they wanted to use.
So that's great. So in other words, Databricks does not shepherd you towards a single framework or a single type of algorithm. It allows you the flexibility to bring the algorithms that you're familiar with into the Databricks product.
That's exactly right.
Okay, great. And so another question just popped up here, and I believe it might be for Stephen, if you're able to answer this, of course, Stephen. And the question is simply, what time series database do you use in the product? Are you able to share that information with us?
So to answer your question, what we're doing is we're taking the data directly from the sensors, and we're streaming that directly. So we're typically not using a specific time series database. We tend to store the information just in Amazon S3 storage, which allows us to handle the data in quite a flexible way.
Excellent. So you've sort of you made your own in-memory persistence for time series data. And I guess what I'll do is, if I may, a shameless plug. If you're interested in time series databases, I would encourage you to take a look at Amazon TimeStream. It's a newly announced time series database that if you don't want to take the route of a QB and develop your own in-memory schema, you could take a look at that for your time series data. And now let's see if we have any more questions here in our question bag. That looks like that might have been the last one. So I would just one more encourage you, if you have a question, now's your time to ask that question and get answers directly from the source. Otherwise, we may be able to give you a few minutes of your time back today. All right, it looks like there are no additional questions. So with that, I want to thank everybody who's taken time out of their busy day to listen to us. I know how difficult it can be to spare an hour, even though it seems like an hour is not a long time. When you get that busy day started, it can be a terrible inconvenience. So thank you for taking the time to listen to us. And once again, if you have any questions at all, feel free to reach out. And this webinar will be delivered to you via link in an email shortly. Have a good day. Thanks.